Hello, grade 7, and welcome to our first math session. I'm Miss Sarah. I'm going to teach you this year mathematics. Hope you are all good and doing well. Our first lesson is about powers. At the end of this chapter, you will be able to use the notation a to the power n, put in the form of a power the product and quotient of two powers of a positive numbers, put in the form of a power the power of a positive number. So let's start. What do you know about powers? Do you remember why do we use powers? And what do powers indicate? From the last year you already took powers, so let's think. Who can relate this lesson with our daily life? Of course, we have powers because it is related to our daily life. Let's watch this video.
A frog population doubles every 3 weeks. If at present there are 10 tree frogs, can you find the number of frogs at the end of 6 months? At the end of this lesson, you should be able to define exponents using positive integers, write numbers in exponential form, evaluate numbers written in exponential form. At times, when we come across very large numbers, like when we talk about the solar system, the mass of Earth,
A very big
distance of
number.
Earth from the Sun and Saturn from the Sun, are all very large numbers. These numbers are difficult to read, understand, and compare. So, we need a better way to represent them. In our day-to-day life, we often use abbreviations as short forms for a big word or name of an entity. Like UNESCO is the acronym for United Nations Educational, Scientific and Cultural Organization. Similarly, we use ISRO for Indian Space Research Organization and SBI for State Bank of India. Have you ever thought why we use these abbreviations? We use abbreviations because they give shorter, easier to remember words for large names. Is there a way we can do something similar with numbers? Now, we take a large number like 10,000. It can be written as 10 multiplied 4 times or simply as 10 to the power of 4. This representation of the number using a shorter term is done using exponents. Here, 10 is called the base, which is the number that is being multiplied, and 4 is the exponent, which represents how many times the value is being multiplied. This is read as 10 to the power of 4 or fourth power of 10. So, exponents are shorthand for repeated multiplication of the same numbers by itself and can be used to represent very large numbers in an easy to understand way. Till now we saw numbers with 10 as the base. Can we express numbers like 27 in exponential form? "27 can be written as 3 into 3 into 3 or 3 to the power of 3. So, exponential representation of numbers need not have only 10 as the base. We could have any positive or negative integers as the base.
So after watching the video, we conclude that what is the main reason of using exponents or powers? We use exponents as an abbreviation of the repetitive multiplication of numbers. When we have repetition of numbers, instead of writing 2 times 2 times 2 times 2 times 2 times 2 6 times, we can write 2 to the power 6. So, what is a power of a number? A power of a number have this shape. It is composed of a base and an exponent. 2 to the power 4 indicates I'm going to multiply 2 by itself 4 times, which is 2 times 2 times 2 times 2, which is equal to 16. Okay, what does the base indicate? The base indicates which number I'm going to multiply by itself, and the exponent indicates how many times do I multiply this number by itself. 16. Okay, now let's see. How can I read a power 3? Exponent 2 can be read as 3 to the power 2 or 3 exponent 2, or we have special case, we can read it in an easier way, which is 3 squared. When I have exponent 2, I say 3 squared. Oh, if I have an exponent 3, what do I say? 5 to the power 3, 5 exponent 3, or 5 cubed. When I have exponent 3, I say cubed. Okay, now can you find the answers of 3 to the power 1 and 3 to the power 0? Let's start. I want to find the answer of these numbers. What do you think 3 to the power 1 is equal? And 3 to the power 0, let's start with the 3 to the power 5. 243. 3 to the power 4, 81. 3 to the power 3, 3 times 3 times 3 equal 27. 3 squared, it means I'm going to multiply 3 by itself 2 times. 3 times 3 equal to 9. What do you notice? If you notice that the answers are decreasing and I'm dividing this number by 3 to get this one. If you divide this number by 3, you get this one. If you divide this number by 3, you get this one. Okay, from 3 to the power 2 to 3 to the power 1, divide by 3. What do you get? You get 3. Correct answer. 9 divided by 3 is equal to 3. Okay, let's also find 3 to the power 0. Divide this one by 3. What do you get? You get 1. Why? Because we are dividing by 3. So we have to note that any number to the power 1 is the number itself. Examples, 3 to the power 1. We are going to find their answers, and any number to the power 0 is equal to 1. Okay, so 3 to the power 1 is equal to 3. 5 to the power 1 is equal to 5. 10 to the power 1 is equal to 10. 3 to the power 0 equal to 1. Keep it in your mind. Any number to the power 0 equal to 1. Okay, let's make sure you understand the ideas. We want to evaluate. Evaluate, it means I have to find the value or calculate these numbers. 2 cubed, it's 2 times 2 times 2, which is equal to 8. 10 to the power 4, pay attention, you can write it 10 times 10 times 10 times 10, or directly I can write 1 and 4 zeros. 3 cubed, 3 times 3 times 3, which is equal to 27. 8 squared, 8 times 8, which is equal to 64. Excellent. 5 cubed, 5 times 5 times 5, which is equal to 125. Good job. 2 to the power 5, it means I have to multiply 2 by itself 5 times 2 times 2 times 2 times 2 times 2, which is equal to 32. Don't forget that any number to the power 0 is equal to 1. Any number to the power 1 is the number itself. So here I will get 10 to the power 1, 10. 5 to the power 1, 5. And this is the end of session 1. Thanks for watching, and I will give you a homework. Hope you solve it on your copy book. Bye bye.